All right, good evening, everyone. Welcome to Perl 101, the anatomy of a camel. If you don't understand the subtitle, you will shortly. We'll get into what camels have to do with Perl. As I said earlier, my name is Doug Miles. This is the first meeting we've had here at Ticketmaster. So hope everyone enjoys, and feel free to ask questions if you have any. Okay, first of all, what is Perl? Perl, unlike a lot of people think, it's not an actual acronym. Larry Wall, when he wanted to come up with a name for his programming language, actually one of his considerations was to name it after his wife. The thing he came down to was he wanted to name it something, a four-letter word that wasn't already used as a Unix command somewhere and was pronounceable. So Perl was what he came up with, and then they came up with the backronym for practical extraction and report language. But like I said, it doesn't actually stand for that. They just made that up after the fact. If you want to seem educated in the Perl world, you'll either use Perl with a capital P if you're talking about the language itself, or all lowercase Perl if you're talking about the Perl executable. Never all caps Perl, although you see people do that a lot, but it's actually not an acronym, so you don't capitalize it. Personally, I don't care one way or the other, but I figure, hey, this is an intro course, so I'm going to let you know, so you know. It's been referred to as the Swiss Army chainsaw, pathologically eclectic rubbish lister, and there's a reason for that. Eclectic being selecting what appears to be best in various doctrines, methods, or style, composed of elements drawn from various sources. Basically, when Larry Wall wrote Perl, his background being in linguistics, not in computer science, so he was coming at writing a programming language as a human rather than a computer, as you know most computer scientists would approach it. And basically that's what he did, is he looked around at other languages like C and shell scripting and awk and just Lisp, a whole lot of other things. And in his terms, he brought over the stuff that didn't suck and left out the stuff that did suck. You know, whether or not you agree, that's a different, topic for a different discussion. But that's basically what it is if you are familiar with other languages, you come into Perl and you'll see a lot of things that you recognize, especially if you're coming from like a C-based language. It's going to, structurally, it'll look pretty familiar to you. So any questions so far? Not anything too difficult at this point. All right. Okay, basically you've got three basic data types in Perl. In other languages, you may be more familiar with things like ints and floats and doubles and things like that. Perl's higher level than that. Again, coming at it more from the angle of, I'm a person, I want this to be convenient for people, not I'm a computer, I want this to be convenient for computers. Because things like ints and floats are very convenient for the computer and not quite as convenient for users. So you've got scalars, which are variables that hold one value. And you notice the little $sign and the @ sign and the % sign. Those are called sigils, and those are little indicators that tell you what type of variable you're dealing with. So a scalar just holds one thing. If you want that one thing to be the entire text of War and Peace and you have enough RAM on your computer, then hey, you can do that. You can stuff all of that into one variable if you want. You don't have to worry about the memory allocation. Perl just takes care of that for you. That's just, swept under the rug. Don't even think about it. All taken care of by Perl. If you want to know the gory details, that's not for this class. That's for another time. Okay. You've got lists and arrays, arrays being the variable type, and we'll talk more about that when I drill down into it. And then you've got hashes, which comes from hash table. You may also hear it less commonly called associative arrays, which is, I think, the term. I know awk used that term. There may have been other languages that did too. I'm sorry? Oh, okay. There you go. See, and I allegedly know some JavaScript, and I didn't know that. Thanks, Greg. I learned something new. Okay. All right. So basically, scalar is a number or a character string. And Perl really doesn't care which. A lot of other languages, they really care. If you say it's going to be a number, it darn well better look like a number. It's going to treat it like a number. Or if you say it's going to be a string, it better be a string. Perl really doesn't care. So we can just set it into Perl is great, into this variable, and then it will just print it out. This right here, in between the difference between single quotes and double quotes is what's called string interpolation. In other words, if you put single quotes around it, Perl's just going to take it like it is. It's like, whatever's in here, I'm just going to take that for what you said. With double quotes, it will actually look through the string, see there's a variable in there, and replace it with Perl is great. And I'm going to run this later, so you'll see what the actual output looks like. And here you can see I've just declared a number equal to 100. And then I'll print in here that this number within string interpolation. What's actually happening behind the scenes here is Perl takes this number, which is a number, and then once it puts it into the string, it converts it into a string. And it just takes care of that for you magically. So you don't have to worry about it. It just converts it. And here is a more explicit example of that. So you've got a lot of, this word context is very important. There's a lot of context that goes on in Perl. In other words, based on the context of your program, Perl tries to figure out what you mean. And most of the time, not always, but most of the time it gets it right, which is nice. Again, designed for people, not for computers. So it makes it really nice because, at least when I was learning Perl, I would sometimes go, all right, I just learned this. I wonder what'll happen if I try this. And I wouldn't even look it up. I'd just try it. And sure enough, it would end up doing exactly what I thought it would do. So that may vary. Some people's brains mesh really well with Perl and others not so much. So, you know, some people love it, some people hate it. No accounting for taste. So anyways, you can see here, this, even though I'm assigning it to a variable named number, it's a string, right? It's got quotes around it. So, but I'm saying number is equal to number plus 1. This is a number. So what Perl does is this would be what's called numeric context. And Perl goes, oh, that string that looks like a number, you're using it as a number, so I'm going to convert it to a number for you. And so, sure enough, this value will be 2, as you would kind of expect it to do if you were just a human going, oh, here's a 1 and there's a 1. You don't care if they're strings or numbers, just add them together. They both look like numbers, and Perl makes sure that they are and just does what you want for it. And then again, we've got interpolation, so it converts it, even though it's a number here, it converts it back to a string when you need it to be, when it's inside the double quotes. And here is another more explicit example, number to string conversion with concatenation. The little dots there just mean concatenate these things together. You don't really have to do this. This is kind of redundant. Normally you do it this way, but just to show you explicitly, now, again, we've set it to a number, but since we're concatenating it with a string, Perl converts it magically to a string for you. And then here, again, I'm showing you explicitly the difference between single and double quotes, so I won't beat that to death. Double quotes, you can tell even by the coloring that Vim gives me, that here you can see this string is different than this string just because of the color. But what this will do is, this will put Larry Wall created in place of string. This one will not do that. because of the single quotes here. And also, you may have noticed these \ns I hadn't talked about. Those are just new lines. So I'm just throwing those in there to format the output nicely when I run this. And the one other thing we'll talk about with scalars is undef or undefined. Basically, undefined, if you've ever done database work, you're familiar with the concept of null. It's basically the same sort of concept. It literally means we don't know what this is. It's undefined. Every variable that Perl creates, you noticed I didn't do any magic declaration. I just created these variables and assigned them to things. By default, if you don't assign it, its value will start out as undefined. So it's not like C where you got to make sure it's initialized to a proper value, otherwise it'll be random garbage, you know, that sort of thing. It's always going to be undefined. So, but again, Perl being Perl, if you try to use undefined in certain ways, it tries its best to figure out what you mean. As a string, it comes up as an empty string. So basically the same as two quotes right next to each other with nothing in between them. So it's nothing, right? It's undefined, it's nothing. And then as a number, it will actually coerce it into a 0 because that's the closest version of nothingness that we've got in numbers, right? It's 0, so nothing. Any questions before I actually run this? Anything at all? Okay.
I guess I do have a question.
Sure.
So is it possible to check if a variable has been initialized or if it's undefined? If I'm like trying to trace what that variable is, would it come back as undef or would it come back as?
If you use, there's a function called defined, and it will return true if it's defined, meaning anything other than undef. Or if it's undef, then it will return false. So yes, that will tell you whether or not it's defined. And if you've assigned it to 0, that's not the same as undefined. It's defined as 0. So yeah, good question. All right, so we'll go ahead and just run this. I should make this bigger here so everybody can kind of see it. So you can see in the string example, we just said Perl is great. There's Perl is great. There's our number example. String to number, you remember we took a string 1 and a numeric 1 and added them together. Sure enough, the value comes out to be 2. And then we had a number 1 that now we're using as a string. And you remember the interpolation, that was the double quotes where we get Larry Wall created Perl. And here is the interpolation, or without interpolation, the single quotes. It puts \n $string, \n, it takes you very literal. You're in literal mode there. Just whatever's in there, that's what it's going to print out. So I tend to, a lot of people use each set of quotes, you know, kind of however they want. My way of doing things, and you can take this or leave it, is I'll use single quotes unless I need double quotes. So I just tend to default to that. Not everybody does that. You'll see single quotes or double quotes sometimes when there's no variable in there. So it doesn't need to interpolate. It still looks to see if it does, but that's how I just tend to do it, is if I'll use single quotes unless I actually have a variable in there somewhere, and then I'll use double quotes. So any questions on the output so far? Does that all kind of make sense with how I explained it? I hope so. Because either I'm lying or Perl's lying or we're both lying. I don't know which. All right. So now we'll talk about lists and arrays. Oh, also I should have asked, is that large enough for you guys in the back to see? All right. So a list is ordered scalar data. You can think of it like a shopping list. If, you know, milk, bread, pizza, cookies, brownies, whatever. Shopping list, it's in a certain order. There you go. It's just, yeah, I was just making up random stuff. Yeah. Okay.
Is it ordered like a set?
Yes, it is ordered. The order matters.
I said that wrong. It's in some form of ascending or descending order.
Yes, it has a specific order. An array is a variable that holds a list. A lot of times when you talk to people, they will use array interchangeably. Sometimes when they mean a list or they mean an array, they'll use the word array in both cases. This is one of those cases where, again, I'm telling you the right way, but not everybody in the real world necessarily talks that way, so I want to give you that warning. But at least you've been shown once what the difference is between a list and an array, so hopefully that makes sense. A list is the things, an array is the container that holds the list of things. Does that make sense? So I'll show you some concrete examples. See, this is a list right here, just in parentheses, 1, 2, 3. That's a list of numbers. There's no variable here. You don't see an @ sign or anything here to show you there's a variable. That's just a hard-coded list. Here is the same thing, just showing you another way of doing it. This is the 2 dots are the range operator. That'll give you 1 through 10. And here's a list of strings. These 3 people being the authors of the Camel book, which is where our subtitle comes from. The Perl Bible, as it's termed, is also called the Camel book because if you're familiar with O'Reilly's books, they like to have animals on the front, and on the front of the Perl book is the camels. So a lot of times it's just called the Camel book. Larry being Larry Wall, and Tom and Randall, you don't need to worry too much about that. But anyways, they're the authors of the original one. I'm not sure with the latest version whether or not all these people are still on it or not. Okay, so now we've seen hard-coded lists. And you remember the \n's, these are just to format my output nicely. That's why I'm skipping over them. They're not really important to what we're doing here. I'm just making sure when you print this out, it's readable. So with an array, now you can see we've got @author. This is a variable. So over here, we've got a list that's going into this variable. So the variables, the array's the container, and over here's the list. And then you can print out author, and I'll show you, I'll make a distinction on how Perl prints out arrays a little later when I run this. Go ahead.
Back to my original question.
Yes.
With your lists, if you put that 2, 3, 1, when you printed it out, would it print out 2, 3, 1?
It
or
would.
Print out 1, 2, 3.
It would. It would be 2,
So
3,
they're
1.
not ordered in the sense
They're-
that they're compared to each other. They're
No,
ordered
the order
sense
in
of
the
order you put them in.
Exactly.
Okay.
However you declare them, that's the order they're in. That's a good point. Good question. Okay, so now we're going to look at, well, how I've got this container with stuff in it. How do I get that stuff back out? So to look at a single array element, we've got author, right, which matches this up here. We've got the square brackets and 2. Now arrays are indexed. In other words, it's got numbered slots. You can think of it as, you know, a row of mailboxes where instead of people's names, it's just got a number. But the important thing to remember is the first number is 0, not 1. A lot of computer languages start counting at 0, so you may or may not be familiar with the concept. But the first array element is element 0, then 1, then 2. Since we have 3 things in here, that's all the further it goes. This is 0, this is 1, this is 2. There isn't a 3 unless we added something else in there, and then there would be a 3. Although Perl doesn't care if you ask for one, but I won't get into those details for right now. Okay, so this right here is going to pull out 0, 1, 2, right? It's going to pull out Larry, because I said Larry created Perl. Larry Wall is the creator of Perl. So that's what it's going to print out. And again, double quotes, so we've got interpolation. Now, the thing you might be puzzled about is the $ here rather than the @ sign. The reason there's a $ here is that indicates the thing that you're accessing. Since we're using an array, but we're only accessing one element of it, that means it's a scalar, right? Scalar meaning just one thing. So even though it's an array, we're only accessing one piece of it, so that's why it's got a $ in front of it. So if you've seen that before and you're confused as to why, that's why. It's because this will tell you what the rest of this is, whether it's one thing or many things. So in this case, it's just one thing. So then we've got 2, 1, 0. So we just list them in reverse order manually. So it's Larry, Randall, Tom wrote the camel book. Now you can also use negative indices. So -1 wraps around to the beginning. This is -1. This is -2. This is -3. You're not going to see a lot of this. Every once in a while, it can be hugely convenient to use it, but most of the time you're going to confuse people. So don't use it unless you got a really good reason for it. But I just wanted to let you know that you can actually do it.
Like what? What's a really good reason?
Give me a second, because I'll have to think about it. I've got a piece of code that I used it in that I thought was really clever. I might be the only one though.
Okay.
Go ahead.
Okay, first of all, if we're dealing with an array and
Uh-huh.
the first item in the array starts at 0,
Yeah,
okay, why is it -1 instead
that's
of
a very good
0?
question. Yeah, the reason is because where you're starting. If you start counting at the front, then it's 0, 1, 2.
Right.
With negatives, you start counting at the back. Okay. So you go, okay, I'm already at the end, -1, -2, -3.
Backwards, isn't that? Yeah, negatives work backwards through the list.
Oh, am I?
Negative one
Okay.
is the end of the list.
Yeah, sorry.
I guess, yeah. We'll see what the
Thank you.
variable says.
Yeah, thank you.
For an example, would it be like
Hold on.
maybe a list of the 50 states and you want...
Well, let's run it before we get any further. Yeah, no, there is no -0 as far as I know. I haven't tried it, but yeah, I'm fairly certain it doesn't work. Well,
Rows and -1.
I'm sorry?
If you mix rows and -1, whether it will recognize?
It would be the same thing, but again, this is one of those things. Sometimes I'm throwing things into this talk just so if you ever see this in the wild, you'll kind of know what it is, but it's not necessarily something you're going to use a lot. And this is one of those things. But let me go ahead and run it, and we'll see whether or not. Okay, so let's scroll back up here. So let's see, I gotta go back so I can see where I'm at. Okay, that would be the second one of writing the camel book. So, all right, so now I'm gonna say this again, we'll see if you people agree or disagree, the ones that were questioning what I said before. So, let's go back. You notice in the output, they're both in the same order, right? That's the important thing to note on this page. We'll go back here. So 2 is here, 1 is here, 0 is here. -1, so 2 would be Larry, and you know what? That's right. Sorry, guys. It's been a while since I've given this talk. This is great. I was actually wrong. Sorry. This is -1, -2, -3. Now it probably makes more sense based on why you were confused. I apologize. I was saying it the wrong way. Well, and you can see why I don't use this often. It's probably been like 15 years since I've used this, and I forgot. -1, -2, -3. Thank you all for keeping me on my toes. I knew Greg feels validated in coming tonight.
It actually might make more sense if you think about it as offsets as opposed to
Yeah.
numbered positions.
Yeah, that's
It
true.
makes sense to go
Offset of
-1
0,
offset
Yeah.
or 0 offset going left to right.
Yeah, I apologize for the confusion. So yes, that's the way it works, is -1, -2, -3. All right, now we'll go on to array slices, which now maybe this whole $ versus @ thing will make more sense. What an array slice is, it means you're pulling out more than one thing at a time out of the array. So here you'll notice I've got 2 indexes. I've got 0 and 1. That means I want 2 things out of this. So I have to, if I put a $ here, that wouldn't be right because that means I'm only pulling one thing out. So you have to use the @ symbol here to indicate that you're pulling out 2 things. So I'm doing 0 and 1, 1 and 2, and then 1 ... 2, which is, this is the same. Both of these will give you the same output. Does that make sense so far for an array slice? And again, this is one of those things that's maybe a little less commonly used, but more commonly used than negative
So that's
indices.
not a multi-dimensional array. It's
No, it's just you're pulling out more than one value at once. Yeah, it's just kind of a convenience thing rather than making you explicitly say every index. You can just, pick and choose which ones you want and pull those out, which actually I did some of that today. Maybe that's a good concrete example. A program I actually wrote today was generating a report that had certain columns, and all of those columns, all the data was being stuffed into an array. But I only cared about certain columns. I didn't want all of them in my final report. So this is the kind of thing I did, is I did an array slice where I just told it, I want 1, I want 2, I want 5, I want 10, and 11. And those were the only ones that pulled out. So you can do more than 2. You can do as many as you want in there. Does that make sense to everybody? It's when you got a list of things, but you don't want them all. You just want to pick and choose which ones you want to pull out of there. Okay. Array in scalar context is, again, we're talking about context. So this is Perl figuring out what you mean by how your program is structured. You notice this over here is a scalar, right? This over here is an array. Well, we can't stuff an entire array into a scalar, right? Doesn't make any sense. Scalar is one thing, array is potentially many things. So what happens is Perl looks at this scalar context and it goes, oh, I'm going to give you something useful rather than just throwing an error and saying, hey, I can't do this. What it'll do is it'll give you the actual length of the array. So it'll tell you actually how many things are in it. Now this will be the actual count, not the index of the last thing. So you got to keep those things, because you remember we're starting counting at 0. So those 2 numbers will be 1 off from each other. The actual count being 1 larger than the last index, right? We've got 3 things, but the last index is 2 because we start counting at 0. Does that make sense to everybody? Hopefully I didn't screw that part up. That's what, this will teach me to go like 10 years between giving this presentation. Make me remember stuff that I've forgotten. All right. So this right here is just an example of printing it out. Here is printing it out in scalar context because of the concatenation operator, the dot, is a scalar operator, so that puts this in scalar context. And some of this will make more sense. I'll kind of wait and show you the output on some of these. Okay, this right here is a special variable, $pound. This is a special sigil. That will give you the index of the last array element. So in this case, array length would be 3. This is going to give us 2. Does that make sense to everybody? So you could take this and subtract 1 if you want, but Perl is being nice for you, I guess, and giving you a way to do each one of those. Because sometimes you want to know how many things are in it, and sometimes you just want to know what's the count of the last thing in it, what's the index of the last thing, so that you can start from the beginning or the middle and go to the end. So it depends on what you're trying to do. Okay. Now, the other thing that's nice about Perl arrays is you get to treat them like a stack. And depending on how much programming you've done, maybe you may or may not be familiar with what a stack is. You can think of it, if you're not familiar with it, like at a cafeteria restaurant, stack of plates with a spring at the bottom. So you take something off the top and the next plate pops up, right? You take another plate off, the next one pops up. So basically, what you can do is, you notice with push, that's like me being the dishwasher who's washed a bunch of dishes. I've got the clean plates, so I push them onto that stack, right? I put them on top, spring compresses, I just keep putting more and more plates on there. So what I do is I take author, which, if we got to look way back up here, is still Tom, Randall, and Larry, right? So I push my name on there. Well, I'm not the author of anything, so, but it's just an example. So we're pushing this on there, and then we're printing out what that will be. Now this is on the end of the array. So it's like sticking a plate with the word Doug on the top of it. Then pop does the inverse of that. It's like taking that plate named Doug and taking it off of the stack. And then if you have a scalar value over here, it'll put that value in there. So now yeah, right contains Doug, because yeah, right, I haven't written anything. So if you didn't have this variable in the equal sign, it just tosses it into the bit bucket. It takes it off the stack and breaks it on the floor or something, however you want to think about it. So, and again, I'm just printing out what the values are so you can see what's going on. When I run it, it'll make more sense. Now, unshift does the same thing, only it does it on the front end of the array. So unshift will put Doug in front of Tom, Randall, Larry. I forget which order they were in, but it will now make me the 0 element and shove all the other ones down. So it literally will renumber the array for you based on putting a new element in at the beginning.
I'm confused.
Yes.
You're saying it operates like a stack, and when you push it, it pushes it on top, which puts it in the 0th offset.
No, well, this part was the stack part. This is like a inverse stack or something. I don't know what you'd call it. This is doing stack-like operations on the other end of the array.
Push and pop. So unshift
So push
and shift, is it on the other end?
Yes, it's on the beginning rather than the end.
Pop up right on the head.
Well, the head being, it depends on whether you think about it sideways or vertically.
Well, no, but in the first element is the 0th offset. So when you add something, you move everything else down, and then you have a new 0th element.
No, well, push and pop work on the end of the list, not the beginning.
Yeah, well, maybe we'll cover that later. I'll straighten that up with you, but yeah, yeah, what he said, first in, last out. So if you're thinking about the plates, first plate the dishwasher puts in is.
Okay, I got it.
Okay, all right, good. All right. Okay, and again, once we see the actual examples, it'll make a lot more sense once it's concrete. Now, unshift isn't used really all that much. Shift, actually, you end up using a lot for reasons I probably won't get into in this talk. But what it does is it takes that 0 element, takes it off, and then renumbers all the rest. So now the array is basically between these two steps. I shoved my name in front, and then I took it back out again. So now the array looks like it did at the beginning, right? In both cases here, I stuck it on the end as the 3rd element. Here, I stuck it in the beginning as the 0 element, but each time Perl does the right thing and renumbers everything so that it still all makes sense. In other words, it doesn't leave a hole when you take it out. It shuffles everything down so that all the positions are filled. And then I put in join because it is basically a function that whatever string you give it here it will put in between each element. And that's usually what, a lot of times what you use join for, is to kind of format an array nicely. In other words, I want to print it out with commas and spaces in between it. So it's just going to do that. But it doesn't put one on the end. That's why join is nice. It literally only puts them in between. So it's not the same thing as like looping through the array and just putting a comma at the end, because then you'd end up with an extra comma on the end. Join just puts them in between. Got to keep an eye on my time here. All right. Any questions before I show you the output? Okay.
I think you already ran it.
Oh, yeah, you're right. I did. Thank you. Okay. So, yeah, I'll just scroll back up and we'll just cover the parts we didn't already look at. So we ended right around here because we were talking about this, and I completely blew that and got it all wrong. Now you notice here when I printed these out before, when I just said print, array, whatever, well, Perl just dumps those things out. That's not nicely formatted. There's no spaces in between them. It just dumps them out because you said, hey, print these things out. And Perl says, okay, I'm going to print them out. And it does that. So you notice this is the 0 and 1 and the 1 and 2 and 1 and 2 examples I had. Here you notice that it's 3 elements long. That was the one, you remember, the array assigned to a scalar gave us 3. So in scalar context it says 3. And in list context, you notice it just prints out everything that's in the array. Again, no special formatting. It just says, oh, hey, you want these things. All right, the last index, you remember that was $pound, is 2, right? And you remember how I said those will always be one off from each other. The number of elements in there is 1 greater than the index of the last element because we're starting at 0 rather than 1 to beat a dead horse. And you notice here the push example dug on the end of the array, right? The pop example, dug is now gone, and then I put it into another variable, and there it is. So here's unshift. You notice dug is at the beginning, and then shift, we take dug back out of the array, and it's in its own variable. Is that a little clearer now that you see a concrete example of it? Sometimes people get confused because, yeah, in stacks, you're usually thinking vertically, whereas arrays, you're kind of thinking horizontally. So you got to kind of turn it in your head sometimes to think about it. Okay, and then the reason that why I put the join example in here is because nobody wants to look at all of this garbage run together. So if you, oh, I didn't have a space in there, I just had a comma. But if I wanted to, I could have had a comma space, or I could have had a tab character, or just a space, or a colon, or pipe, or whatever the heck you wanted. So you use that a lot of times when you want to output an array and make it look nice. So that's why I gave you that example. Any questions here before we move on? Okay. I'll take that as a no, or everyone is completely lost. All right. The last data type we're going to talk about here is our hashes. Okay, a hash is a variable that holds a mostly unordered list of key value pairs. What that means is, oh yeah, map. Sometimes in some languages it's called a map. Let's say, for instance, you want to map. This is terrible, never do this, but I'm sure a lot of companies do something similar to this, like social security numbers to names. So the key would be the social security number, so you type in somebody's social security number, it looks it up, and it gives you back their name. Okay, so it's key value pair. You've got some kind of key, and the key needs to be unique. The value doesn't. The values can be repeated, but the key is, again, you can think of, let's go back to the mailbox analogy, you know, where like when you were in grade school, a lot of the teachers just had these open boxes, right? And they would have their name. So the key would be the teacher's name. The value would be whatever piece of paper is in there, right? So you look it up by name rather than number. Does that make sense to everybody? That's kind of the difference between arrays and hashes. Arrays, you access things by the index of the position where it is. Hashes, you look them up by the key. Whatever the name of that thing is, then you pull out the value. We all good so far? Because if you don't understand that part, the rest of this will probably be gibberish. I made this example up a long time ago, a couple of companies ago, so I gave myself a huge raise. So yeah, that's a pretend number. Anyway, so I've got a hash here, and you notice I'm using parentheses, just like I did with an array. That's because Perl can take a list, and as long as it's even numbered list, right, because it's key value pairs, it can take that list and then put it into the hash. It just goes key value, key value, key value. So if you have an odd numbered list, it's probably not going to do what you want. But as long as yeah, exactly. What Greg just said, the last value, the last thing that's actually there will be a key, and then the value will be undef because there's no corresponding value to go with it. So Perl just sticks one in there for you. Okay, so this kind of makes sense, right? This is the key first. This is my first name, the value. Key, last, value, miles, blah, blah, blah. Hopefully this makes sense. All of these over here on the left are keys. All of these over here are values. Now this arrow, a lot of time is called the fat comma, because you actually could replace all of these with commas, just like a normal list, and it would work. But what this does in addition to that is, if none of these keys have spaces in the name, you actually don't have to put quotes around them. So it'll kind of just, it makes it a little convenient so you do less typing. But other than that, it operates basically like interchangeably with a comma. But this makes it a lot more clear what you're doing, right? If you just had a comma, it's not as clear that this is a key and this is a value. Here, it's a lot more clear. This is key, this is value, and that is the thing that tells you these two things are associated with each other. Does that make sense so far?
Is a hash in Perl actually an even numbered list? I mean, is that what it's actually using under the covers?
Oh no, under the covers it's actually using a hash table. Yeah, yeah, exactly. So now, again, now we've stuffed a whole bunch of stuff in the employee hash here. Now, how do we get that data back out if we want to do something with it? Well, you remember from the array, it's pretty similar. You remember our $sign. If we're only getting one value out at a time, we're going to have a $sign instead of the %sign. And then you have the curly braces or braces, depending on how you like to call them. And then you notice in here is the key. So employee last, we look it up here, what's the value? Miles. So this whole thing right here gets replaced with miles. And then employee first gets replaced with Douglas, employee middle, middle initial. So does that make sense to everybody? You go through each key and you say, when you give it the key, it gives you back the value. So you want a key, you give it a key, you get back a value. All right, you can also do a hash slice, which again is not necessarily as common. Most of the time you'll just pull one at a time, but sometimes you want more. You notice here, now we've got an at in front of it, because that again tells us we're taking out more than one thing. So here, I just list more than one key, just comma separated, and it will give me first, middle, and last the values out of there, because I'm giving it keys. It's going to give me back values. So now, hash flattening is basically the inverse of what I just said here. We took what's basically a list with an even numbered count of quantities, and we put it into a hash. But you can do the same thing. You remember we used join with arrays before, right? Well, we can go ahead and use this hash as if it were an array, and it will give us key value, key value, key value. The catch being, you don't know what order they're going to come back in. In arrays, things are in the order you put them in. In hashes, they're in no particular order. You should treat them as if it's a random order. You don't know what order they're going to come back in. Under the hood, there is, Perl's got a rhyme and reason for why it orders things the way it does, but you as the end programmer, you just consider it random. You have no idea what order they're going to come back in.
Key value pairs back together?
Yes, the keys and the values will always come together, paired.
Key value.
Yes, but you have no idea. It may come back with salary first, then company. Yeah, you don't know. But the two things will always come together. So key and value will always match. Okay, so, and we'll show that. And again, this time I put the space in there. So I thought I did last time. It was in this example. All right, you can use hash in a scalar context. This is almost trivia here. So you can, if you're going to forget anything I say tonight, let it be this. This basically tells you how efficiently Perl is storing your data, your data set under the hood. So it gives you a number of buckets. Again, I'm just telling you this in case you ever see it, but most of the time you don't need to really worry too much about what this means, unless anybody out there who's experienced can think of a good example of where you've used it. Okay, nobody's coming up with a good example. Okay, so now we'll look at the keys operator. Keys does what you probably would expect. It gives you back only the keys. So it's going to give you back a list of the keys. Again, you have no idea what order they're going to come out in. They're going to come out in some order, but it's only going to be these things, not necessarily, and it's unlikely in this order. It'd just be some kind of random order. So here I'm just printing them out, and then here I'm putting a join in so that you can see them a little more nicely formatted.
If you dump those into an array, can you sort the array later?
Sure, yeah. Okay. You can absolutely do that. So what each does is it gives you, each you'll use in a loop, so this is kind of a goofy example, but what it'll do is one at a time, it'll give you a key and a value, the two that go together. But then it says, okay, here's the first key and value. Again, in no particular order. And then you'll go through a loop and process it. And then it goes, oh, here's the next key and value. And then you'll go through the loop. So in this one, it's just going to grab whatever the first one is. And at least I think it is. Or actually, it's in list context. It might grab all of them. Does Greg want to say that he knows for sure what it'll do? I guess we'll find out when we run it. Again, it's kind of a silly example because really you use it in loops, but the reason I'm not doing a loop here is because we haven't talked about loops. So skipping that. Okay, now exists will tell you whether or not a key exists in the hash. It's not saying anything about the value. It's not saying whether the value is 0 or War and Peace or undef or anything. It's telling you that in this table, a key, this key exists. It'll return true. If it doesn't exist, it'll return false, that it doesn't exist. All right? And then delete allows you to actually say, okay, I don't want this in there anymore. And you just delete it by key, and it will return whatever thing you, or does it return the count? The value. Okay, that's right. Yes, the value. I'm sorry, confused myself there for a second. The value of whatever it is you deleted. And then you can see here, the reason why I'm doing that is I'm showing you an exist where it does exist, then I'm deleting it, and then I'm showing you an exist where it doesn't exist. All right, are we all good before? Yes, go ahead.
when you were explaining array,
Uh-huh.
and you gave an example where it used a scalar, okay, you were using parentheses, and here you're using curly braces. Is
Oh,
there,
actually, well, for arrays, it's actually square brackets when you're putting the index in there.
okay,
So yes, they are different between the two. For arrays, it's square brackets, and I don't think I pointed that out, so thank you for bringing that up. And then for hashes, it's braces
okay,
they use, yeah.
okay.
All right? So let's go ahead and run this. And oh, it looks like that almost fits. All right. So you can see here, this is where I was accessing each one by one at a time, right? By giving it the key where I said last, comma, first, space, middle. So that gave us what we wanted. Here's the hash slice where we got all three values at the same time. We just said, okay, we want first, middle, last. You remember those were in braces with commas in between, first, middle, last. And then here's the flattening example. You remember I said no particular order. So in fact, this may, on different machines, it may run differently. It will definitely give you different orders if you change, like if you add something to the hash or you delete something from the hash and then you dump it out again, the order may be completely different than it did it the first time. That's why you should just always pretend it's random. I have no idea what order. Never depend on hash order.
It's even more random in 518.
Exactly, yes, that's a good point. That, yeah, they've actually intentionally, for security reasons, tried to make it really, really random so that hackers can't try to guess what order things are going to come back in. Okay, so, but you notice, true to what I said earlier, these two things do come together though. Middle E, department, internet services, first, Douglas, position, pro programmer extraordinaire, blah, blah, blah. You see the two things come together, but they're in a jumbled order, okay? Here's the whole bucket thing. Again, who cares? Pretend I never brought it up. I just, for the sake of completeness, it's in there. If you ever get asked that for an interview question, you can maybe go, what? Doug mentioned that in a presentation once. But yeah, that's almost trivial. Okay, you notice keys here. These are all the keys, but again, you notice they're all run together. So I went back with the join and formatted them nicely. So these two are really the same thing. This is just using join to format it nicely so you can read it.
So those
You
came out
noticed
in the same order
they came out,
both times?
yes, they came out in the same order both times, but you shouldn't count on that, especially
okay. So
if
that's-
between those two lines, if I made any changes
That's
to that
an
hash,
anomaly.
well, if I made any changes to that hash between those two lines, all bets are off. It could come out in a completely different order. So again, yes, you may notice that it does this, but don't ever depend on this. Just don't depend on it. Because I guarantee you, you will curse yourself later because it will come back to bite you. So here, oh yeah, this was the each example. You remember how I said it just gave me the first one, middle E. Well, if I was in a loop situation and I went back to the beginning of the loop, it would give me another key value pair, key value again. But we'll see that more when we get to loops. We haven't really talked about loops yet. So here are just all the values, which does, the inverse of what keys does. Keys gives you all the keys, values gives you all the values. And again, I just format it nicely. Here's the exist. The first time the key exists, I delete it. And then you notice I get nothing back, which is false because it didn't exist after. You remember it was in there to start with, then I deleted that key, then I check again and it's not there. Does that make sense to everybody? Any questions so far? Okay.
Wouldn't it be like push and poke kind of similar for the hashes?
No, the reason being for a hash, you've got two definite endpoints, right? You've got the start and you've got the end. So push and pop and shift and unshift kind of makes sense. A hash, you could almost think of it just like a bag of things that are joined together. You just reach in there and grab something out and, or you reach in there saying, I want, first name, and you reach in and you grab it. But inside the bag, there are no particular order. So there's really no way to do like a push or a pop. If you want to add a value, you just say $hash and then braces new key, whatever the new key is, equal new value, whatever the new value is, and it just puts it into the hash for you. Does that answer your question? Okay. We'll see whether or not this was a mistake, because this actually originally was like a 2-hour presentation when I first did it, but I'm trying to keep it down to somewhat less than that, so we're not here all night. Okay. In programming languages, true and false is a very important concept. With Perl, the easy way to figure out is what's true and what's false is worry about what's false first. Because the set of things that are false is much, much, much smaller than the set of things that are true. So 0 is false. So if you're testing for, true or false, 0 is false. Empty string, this is not double quotes, it's 2 single quotes next to each other, is false. And undef, you remember I said earlier that it would convert into either empty string or 0. Well, it's in that, the reason it'll do that is because it's in that same set of things that are false. Everything else is true. Everything. Yes?
You're missing one false.
Oh, what?
Empty list.
Empty list. I guess it depends on which context you're using that in. That's true. All right, good point. Thank you. I'll update the slide. Thank you.
There's one more you're missing actually too. There's the string that contains a 0 and only one 0 character and only one 0 character is also false. So the empty string is false, but a string that contains the character 0 and only
It depends on what, actually that one I think I'm going to disagree with, because I think it depends on the context. If you use it in a comparison, in a numeric context of some sort, it'll treat it as a 0, but if you just use it in a Boolean context, I'm almost positive it'll be true.
Actually, we can sort of try, but I'm pretty
Okay,
sure say
yeah.
if $X.
Okay, yeah, we'll give it a
dollar
shot
contains
and
the
see what
string that
happens.
has 0 in it, I'm pretty sure it'll go.
Okay. All right. Well, thank you, guys. That was good. I left out a couple of things. So empty, yeah, empty hash and empty list, where an empty list would be just 2 parentheses with nothing in between each other. That would be an empty list. Does that make sense? That's also false because there's nothing there. But everything besides those things and the things I left out will be true. So if you've got a string of things, if you've got any other number, negative numbers, whatever, imaginary numbers, doesn't matter. They're all going to be true. All right? Does that make sense? So you can tell it's just much easier. Just worry about what's false. And if it's not in that handful of things that's false, it's going to be true. All right?
Doug, I have a question.
Yes.
Can you always just compare it to undef then?
Not if it's, well, it depends on what you're trying to do. If you're actually trying to find out, is this thing defined? Well, then you'd actually use defined. But
Because
like,
would it convert it for you to like 0 or empty string if you're doing the Boolean?
if you're saying, does 0 equal undef? Yeah, that would convert the undef into 0 or empty string, yeah. But those are comparisons versus just Boolean, true or false. So, okay. Good questions and good points. All right. At least some of these other examples are a little shorter. Okay, now we're going to talk about the structure of a program. We've talked about variables, that's the data of the program. Now we're going to talk about how do you structure your program. One of the most basic building blocks is just a block. You've got an open brace, you've got a closed brace, and you've got individual statements. You'll notice each one is ended with a semicolon. The last semicolon is optional, but don't do that. You'll hate yourself later, or someone else will hunt you down and say mean things to you later. Because as soon as, if you do leave this one out, it'll compile fine, but if somebody comes in here and tries to add another line here, it's going to blow up and they won't be happy. So just know it's optional, but you want it to be there because you're just asking for trouble if you don't. Any questions here? Really not much going on here that we haven't seen before. I'm just printing out a bunch of stuff, just showing that they're grouped by this block. And then we're going to build, you know, the bare block by itself in this example isn't too interesting, but we'll see here why they're useful.
Was the top line, is that the same as a shell script where it tells you what?
Yeah, absolutely.
to use?
Yeah, that's what this, it's called a shebang line. In Windows, as far as I know, it's ignored. I don't know of any cases, but in Unix, it'll look at this first line to figure out what type of a script this is and how to run it. And I'm just giving it the path to Perl.
Blob if you don't put it.
Well, it depends on, you notice I've been typing Perl space blah. I don't even need the shebang line for that because I'm saying Perl run this. This is if you just make it executable. And that's just a habit of mine. Most of the time I put it up there whether I need it or not. So, but a good question. Okay, now we're going to look at the conditional operators, if, else, and unless. And I'm going to probably start speeding up a little bit, so hopefully I don't lose you, but I don't want to go too much over time here. Okay, we've got a variable, scalar, and a value, 1. We say if Perl guru. Now, inside of these parentheses, that is a Boolean context. Boolean meaning true or false, right? Just two values, either it's true or it's false. Well, you remember 1 was not in the set of things that was false, so it must be true, right? So we go into this block because this if, it says if this is true, then it's going to print Larry Wall because, yeah, he's a Perl guru. Else, print Doug Miles. And boy, have I been shown this tonight, considering the number of mistakes I made. This is awesome. Anyway, and going on YouTube. This right here is just the header for the next example. So now we're going to use a string and then do some comparisons for Boolean values. So we say, hi, guru. So if we're checking if it's Perl guru is equal to the string grand high guru, you notice the EQ here, that is the string equivalent to the equal sign for numbers, right? So for numbers, use the equals, or yeah, I'm sorry, double equals. Thank you. I'm getting tired now because I've got no excuse for that. Yes, single equals is assignment. Double equals is comparison of numbers, numeric comparison, and EQ is string comparison of equals. Yeah, I've got no excuse for that one. That was bad. Okay, so grand high guru, well, we didn't set it to that, so this is going to turn out to be false. So it's going to skip this and go, hi, guru, Randall Schwartz. Randall, if you remember, was one of the authors of the Camel. So it's going to go into this one. And you notice this else if, notice there's no E there. If you put an E there, it's not going to do what you think it's going to do. It's else if. I'm not sure, does anybody here know the reason that he picked that other than it's easier to parse that way? I don't know if there was. Could be, who knows? I don't really know the history behind that one, but that's else if. So that allows you to put several different conditions, one right after the other, and basically make a choice amongst all of them.
It stops at the first one that's true, right?
Yes, exactly. So it's going to execute this block. It's going to print out Randall Schwartz. It's going to say, nope, it's not this. And else if, you notice, allows you to specify another condition. Else is just the default saying, hey, if none of these other things were true, then do this. So it's not going to hit this, but if sometimes you have code where you want that to happen. If none of these things are true, do this default action. So That's what else will do. And you know what? For the sake of briefness, and because unless sometimes confuses people, I think I'm just going to skip unless somebody really, really wants to know. Come up and ask me after if you really want to know. It's kind of a different comparison operator that I haven't seen any other language have, but a lot of times it confuses, especially newbies. So I'm going to skip it just for the sake of time here. Okay, now we're going to start looking at some loops. Okay, this is what's generally known as a C-type loop just because it got ripped off directly from C. You've got a for keyword out here. You've got some kind of a variable initializing the value here, then a semicolon. Then you've got a condition that you check, another semicolon, and then you've got something that you do each iteration. Usually it's something like increment or decrement it, or add a value to it or subtract a value. There are other things you can do, but those are the common things. And you notice the plus plus, that means increment by 1. I gave you in the comment, which by the way, I haven't mentioned, this is the comment character. Perl ignores anything after that. This is for people consumption. So this is the same as count is equal to count plus 1. So every time it goes through the loop, it's going to be 1 larger than it was before. It's just going to print that out. We'll see an example. If anybody wants me to, I can go back and run the other examples, but I don't think they're, terribly interesting. So if you want me to, if everybody wants me to, I'll go back, or if you really want me to, come back and see me afterwards. But now for each is, for and for each in Perl are actually aliases of each other, so you can use them interchangeably. A lot of times, and not so much anymore, this is more of a historical thing that people would use for when they were using a C-type loop. But you don't always necessarily use a lot of C-type loops in Perl. Most of the time you don't need them. And then they'll use for each, but I've seen people that would just have for here instead. So just realize you can interchange the two. But what it does is it takes whatever is in this list and one at a time puts them into whatever variable you have here and goes. So first iteration loop, it's going to have Larry. Then it hits the bottom, goes to the top, then Tom goes in. Goes to the bottom, goes to the top, Randall, Doug. It just loops through each one of those. And then the range operator just, again, gives you another example of a similar thing, only the dot dot gives you automatically 1 through 10. It's just a convenience thing. It just starts at this number and ends at this number. So, and this right here is a big reason why you don't need this. Because if I can count to 10 through this complicated mess, why wouldn't I rather count to 10 this way? It's a lot more straightforward and easy.
Can you count through a list without knowing how many objects are in it? Just say, print out the list.
Well, if you do a for each, it will automatically stop when it reaches the end. So if instead of here I had an array rather than a list, it would stop when it hits the last array element. It'll give you that last array element, loop through again, and then say, hey, I'm done, and then it stops.
For each?
Yeah.
Okay.
Does that answer for you?
Yeah.
Okay. All right. Does that make sense to everybody? I'm going to run this one real quick, but
For each ampersand person, and then within the blocks, the for each, the person with a $sign in front of it. If you were looping through
no, it'll, because in both cases, I think I know what you're asking. You notice there's $sign there, because again, we're only getting one value at a time. Even though there's a whole bunch of values here, we're only getting one at a time.
Well, if you look at the for each one, the $sign person says, that's a scalar, right?
Scalar, yes.
All right, if I wanted to loop through an array, and I had no idea how many values had in it, or I didn't want to specify it, if I said for each ampersand person, and then print $sign person, would that do it?
Go ahead, Greg.
The array replaces the stuff between the parentheses, not the dollar person.
Yeah, you wouldn't put an array here. You would put the array over here. If you wanted to like accumulate things, you would do that within the body of it. Like if you wanted to say, well, I want to group these 3 at a time,
No, I just
you would.
want to print out an entire array, and I don't want to specify go from 1 to the 575th element. I just want to say print everything from the beginning to the
Yeah,
end.
that would be the earlier
would be
ones
the
where I
same.
use the join.
Okay.
You would just use join, and it'll only print what's there.
Okay.
It won't give you to infinity and beyond. It just gives you to the last element.
Well, for his question here, it's just everything between the left and the right parent, including the parent, you just replace with at, no, we go up to line 18.
Okay.
Replace that with at people. If you had an array
Yeah,
of people.
exactly. People with these values in it, then this would do the same exact thing it does
$4
here.
person at people.
Yeah.
So the array is people, and the values inside
Values
are the
would be
person.
this. Yeah, so imagine we had an at people equal and then this list, then we could just put at people in here
Replace
and it would do
value.
the same
Okay,
thing.
that's what I was getting at.
Yep, okay, thank you.
Because what it's iterating over comes after what you're assigning each
Yeah,
iteration to.
all right.
Think of it as for each person in people.
Right.
I'm going to do that one real quick, but as you can tell, it's mostly counting to 10 and spitting out names. Just let me know if you have a question. Mostly, I think it's pretty straightforward stuff. Okay, while until and do while.
Do variables
Until-
have block scope if they're declared within a block?
Oh, there we go. More advanced question. Actually, see me after because I'm really not addressing scope in this presentation. I actually have a 201. I'm for the regulars. To have mercy on you, I'm not going to do that one immediately after this one. I'll probably wait several months and give the 201 presentation, which actually talks about stuff like that, scoping and things like that. And I promise if I do that one, I'll do a better job of making sure I actually know what the heck I'm talking about. Because it's been a while since I've done this. A long while, too long. All right. All right, now we're going to look at while loops. While loops basically look at this. This is a Boolean context again. You remember with ifs, it's a true or false thing. And it's saying while this, whatever this is in here is true, I'm going to do what's in this block. So we're saying while $count is less than or equal to 10, print count, and then increment count. So it's just going to keep going until it hits the bottom here, and this has incremented it to 10. It's going to go back to the top and say, oh, this is now a false condition, so I'm not going to loop anymore, and it just drops out. Does that make sense to everybody? So it just does until false. In fact, if you want to do an infinite loop real easy, all you do is say while 1 and open and close paren. That'll run forever unless you've got something in the middle to break you out of it. Because 1 will always be true. Well, actually, if you've got like a long-running process and you want it to run it, yeah, exactly. Yeah, game loops. When you start dealing with things that are event-based and stuff like that, but that's all way beyond 101. So
does Perl have postfix and prefix iterators?
it does, yes. Good question. What he's asking about is instead of plus plus here, you could put the plus plus in front. All that means is whether with the plus plus at the end, postfix, post meaning after, this gets evaluated first, which in this case, since there's nothing else on the line, it doesn't matter whether it's prefix or postfix. But just know that if you put them in front, it'll increment first, then evaluate the variable. If you put them at the end, it will evaluate the variable, then increment them. So yeah, good question. All right. Now, until I'm going to, again, for the sake of time, gloss over. It's basically the logical inverse of while. It means basically while this is false, it's a way of saying while it's false, but it says do this until this is true. Again, not often used. In fact, some people will, beat you over the head if they see you use this. I don't know. I use it occasionally in very specific places, so it's one of those things you don't want to use it
Is that one of those
all the
religious
time.
things in Perl, like echolocation and
yeah.
curly braces?
It definitely could be a religious thing. I'm one of those kind of, if it makes sense, use it, but otherwise don't, because somebody will hate you for it. So do while. Now do is actually not technically part of a loop structure. It just says do whatever this block is. It's really the while at the bottom that does the looping for you. Now, really, all this does is, instead of putting, experienced programmers will know this from other languages, sometimes in a loop, you want to always execute the loop at least once. That's when you would do the do, because it doesn't do the check until the end. So this will always go through at least once, and then it'll do the check at the end. With the while, it may never execute. If it evaluates what's in between the parentheses and it's false, it'll skip over the whole loop and never execute it once. So it really depends on what you want to do. If you want it to always at least go once, you could do the do while. Otherwise, you can use while. That's really it there. And again, I don't think I'm going to run these. These are all just counting exercises again. It's just looping through, incrementing, counting 1 to 10. So not terribly interesting.
So until would be the only different type of a loop between, say, Perl and C and Java and C++?
For the most part, yeah.
Okay.
For the most part. Okay. You know what? Let me see how much of this I have. Okay. I'm actually wrapping up, and I apologize. This is I was hoping I could squeeze it down. It's taking a little longer than I wanted, so if you really have somewhere else you need to be, I completely understand. Don't feel like you have to stay if it's getting too late for you. Because if you're like me, I got like a 30-mile drive after I'm done here. Okay. Now we're going to look at input and output, right? Because most programs aren't very interesting unless they're taking things in or putting things out or doing both, right? Programs usually consume data and then put data out. So right here is a long form example of the shortcut that Perl allows you to do here. You've got 3 types of input and output. You've got standard in, standard out, and standard error. Standard in is usually the keyboard. Whatever you're typing, that's standard in. Standard out is usually the screen. It's just whatever your program, when I say print foo, that goes to standard out. Standard error also by default is usually the screen, but a lot of times it can be sent to a log file instead. That's for, as you would expect in the name, for errors. If something's going on that's bad, or maybe even not catastrophic, but a warning, and you want somebody to know about it, you might put that out on standard error, and maybe they've got that going to a log file that somebody can go back and look at and go, oh, hey, this weird thing happened at 10:15 a.m. I better see what happened. Okay, so what we do is we print a prompt, and then we just say while standard in. You notice this is called the diamond operator, and you notice this is all uppercase. Whenever something is all uppercase in Perl, it usually has a special meaning. That's kind of just a convention that tells you, hey, pay attention. And you notice there's no sigil in front of it. That's because file handles don't have sigils. So it's just saying, while I'm still getting something in standard in, print out whatever the heck it was that I got on standard in, put a new line, and then give them another prompt. So it's prompt, get input, prompt. This one I will run just because it's a little more interactive. And let's see.
Yeah, also if they haven't seen $sign underbar.
Okay, so it's saying enter something. So hi. It just echoes back hi, gives me a character return, and then it says.
So how do you stop it as opposed, other than a kill-9?
Control C works pretty nice.
Oh, okay.
Yeah.
See, that one I know.
Yeah. See.
So
So
if you wanted something to say, to be able to type something in and said, okay, if I get this, I'm going to stop asking.
Yeah, exactly. If you were
put
going to
something
do
like
something
that.
more friendly, yeah, you would put in a check that said, if they typed quit, then quit.
Yeah.
This is just a quick and dirty example of
Okay.
it'll just keep asking you forever until,
And it'll take every keystroke entered
yeah,
as
up
itself until you hit
until you
the
hit
enter key.
enter key. Exactly.
So
and-
what if maybe you wanted to wrap text? I mean, would you? You know, like create lines before hitting enter?
Oh, yeah, basically, yeah, you wouldn't do it
You wouldn't?
this way.
Oh, okay.
Yeah,
handle it.
come and talk to me afterwards and I'll
No,
maybe
I'm
give you an
just
example.
checking.
Yeah.
Okay.
Because the carriage return does tell it, hey, I'm done here. Go on, loop through again. And you notice this is kind of like that while one example I was saying. It'll go on forever until I kill it by saying Control C and I say die, 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 or kill the process, or however you want to do
You
it.
said while one, would it work the same way?
Well, no, because it wouldn't pull in standard in. It would
that
it would
tells it
it would just
also-
keep printing stuff forever. Just zoom, print, print,
Oh, so
print,
that
print,
actually
print.
tells it to check with
To read standard in, and then when you hit the carriage return, it says, okay, standard in is done. Now I'm going to execute the block and then come back again and wait for more standard in.
You can also stop by holding the key down for about 27 years until you run out of memory.
There you go. Or you could play, what was the name of the Doom where you could, when you killed monsters, it would kill processes on your machine? I don't remember the name of that, but they had a version of that. What's that? There you go, PS Doom. Yeah, good times, good times. Okay, basically in this example, I called this one print file because basically what we're going to do is, you notice this again, all caps, this is a special thing. It's called argv, although you could argue it probably just should be called arg. The reason it's called argv is because the equivalent thing in C was called argv. I won't go into that anymore. Just know these are the command line arguments. So basically anything you put after the name of the program on the command line, space, foo, space, bar, space, whatever. Yes, exactly. All of those values will go into this array. You notice I'm using shift because I said earlier you use shift a lot. This is exactly the reason that you use shift a lot. Is a lot of times you may or may not have a bunch of things in an array, but I just want the first one. Give it to me, go. So it's going to take whatever that and interpret it as a file name. And then I use the open command. This is a file handle again. I type this, this doesn't have special meaning, but it's kind of customary to type file handles with all uppercase. Although one could argue I should rewrite this and use my, but I haven't talked about my yet, so that's why we're using file handles. I can see Greg making faces at me. Anyway, so what this says is while I'm still getting things out of the file, and you notice the arrow is going this way, that means I'm reading from the file. If the arrow was going the other way, that I would be writing to the file. If it's a double arrow, I'm appending to the file. At the very least, actually, I should separate this out into 3 parameters, though. I just realized that shows how old this code is. You couldn't do that stuff back when I wrote this example. It's going to print out. Now, you notice this variable, we haven't seen this before. $_, a lot of times it's the topical variable. It just means what is the thing we're talking about at hand within this loop or whatever structure. So if you don't say explicitly $line equals this, then Perl just sticks it into $_ for you. It just says, okay, whatever I got from file, it's now in $_. And in fact, you can go so far, and I would hesitate to say that you could just say print, because Perl's default is to print whatever's in $_. But once you get to, but once you get down to this level, it's really more confusing than helpful. So I don't necessarily recommend that. And then once we're done with all the lines in the file, we processed every line, one line at a time, we're just closing the file. Perl will do this by default. If you leave it out, it won't leave the file handle open. It'll close it.
So
Question?
that sounds similar to what you do in Java, where you're saying as long as the return value is not -1, so it's red align. If there's another one, it's not -1.
Yeah.
So that's
In this
basically,
case,
as long as the file has
this
more
returns an
content.
undef is what it does.
Oh,
It
okay,
returns an undef when it's done.
When there's no
When
more
there's no
files,
more
lines
lines.
to run, it returns an undef and says, oh, that's a false.
Yep.
Okay,
And we're
cool.
going to run that one real quick.
Actually, the special handling of the diamond thing, so if you have a line that just has like a single zero on it, it will not exit valid.
Say that again?
If you had like a line that just had like a single zero on it, it won't exit the loop.
Oh, wouldn't?
No, because it's specifically looking for undef, not a false value. That's the reason for it, because 0 might be valid data, right?
Yeah.
On a single line, 0 might actually mean something. Like I do solar data for my solar system at home. Well, if it's dark outside, my output is 0, right? But that's still a valid value. Just means the
So
sun's
you're
not out.
saying if you actually wrote one line in a file and made it 0, it would never close the file?
No, it would read that as a line and keep going. It'll only return undef when it hits the end,
End of file.
and there are no more. Yes, end of file. EOF.
Okay.
Yes. Okay. What I'm going to do is use this to print out the previous example that we had.
What if you had one line and it was undef?
Well, in that case, it doesn't do anything magical.
It's just a string value.
It's just a string value.
Yeah, okay.
Yes. So no, it won't do what you were hoping it would do. All right. Basically, we just printed out the standard in, which was the previous example. Just printed it out one line at a time. You notice when we reached the end of the file, it quit. It exited out. So we're done there. Perl makes it really easier. That's the funny thing is, as these examples go, they're actually doing more complex operations, but there's less code because Perl likes to make things easy for you. What this will do is, you notice I called this Perl cat. If you're familiar with the Unix cat command, it's concatenating a bunch of files together. So if you give it 10 file names, it'll go through one at a time and concatenate all those files together into one huge output. This right here is like a basic dumb version of cat. It does basically the same thing. You notice I've got the dollar or the diamond operator here with nothing in the middle. That tells Perl, treat every command line argument, you remember @argv, everything that's in there, treat it as if it were a file name, go out, try to open it, read it in, and then loop through with each line, but don't return undef when you reach the end of the first file. You only return undef when you reach the end of the last file. So this thing will keep going. If I have 100 files, if the command line will actually allow that, it'll do all 100 files and only stop when it reaches the last line of the last file. Does that make sense to everybody? So quick run of that. If we say, I'm going to go ahead and just use this. Whoops, I called it Perl cat. Sure, it's not going to. Okay, what it's going to do is concatenate. It's treating these two things as file names, right, which they are, and it's just going to run this program and concatenate the contents of those two files together, assuming I typed everything right. Yep, that's basically what it did. Because you notice this right here is the first line. This is the last line of the previous file, but it just runs them all together, just like the cat command. So does that make sense? That's really useful for, if you're just doing data munging. You've got a whole bunch of data across several files. Maybe they're like log files that are dated, but you want to look at them all together rather than as separate files. It's an easy way to just say, hey, give me all that data, and I'll determine either I'll read it all or maybe I'll stop somewhere in the middle based on some other value. Does that make sense? Any questions? Nope.
Can we format that if you do like this? Like
between the files?
Oh, sure. You could check like the value or the count of how many lines you've gone through, and then you could insert extra data. Like if you wanted, let's say you wanted a dashed line in between every file. Yeah, you could go through and figure out different conditions. As long as it's some condition you can figure out inside the loop, you can put some logic in there to put out
No,
something
that
else.
Additional logic. That while
Sure.
it's not do that way.
Yeah,
While that
basically, you could either put additional logic above this line or after this line. And it'll either print it before or after the line. This will always just loop through each line at a time for every file until it reaches the last line of the last file. That's it. Boy, I'm doing a lousy job of cutting this down from 2 hours, that's for sure. Okay. We're getting close. We're on the home stretch here. Okay. Here we're doing the same thing we saw earlier, right? We're assuming the first thing in argv is file name. And you remember how I said earlier, the double arrow means append. So what it's going to do is just take whatever's in that file and, oh, and sure, here, this one I did change even though. Ignore the my because we're not going to talk about that until the next one. But this is going to append to the file that's with the name of file name. And I didn't really talk about the or die, but this just means if this fails, die, the program just dies and it gives you this error message as to why it died. Usually in cases with file names, either it's because the file doesn't exist or you don't have permission to read or write to it or whatever. Okay, so again, you remember this is pretty close to our other example of have a prompt, read from standard in. Now it's printing to log file whatever you typed in. And then it's giving you another prompt, and then it's closing. So basically it's doing the same thing. Instead of doing it to standard out to the screen, it's going to write it to a file, which the name you give it when you run the program. And it will just log everything you type. So unless you really want to see that, I'll probably skip it because it literally does the same thing as the other one. Instead of going to the screen, it puts it to a file instead. That's the only difference.
What's the purpose of the double pipe before die?
Oh, this is basically is a logical or. It means if this thing is true, then I don't care what's after this because if you're doing like logical ors and you've got a bunch of things stringed together, only one of those things has to be true. Either he's a person or he's a person or he's a person. Well, if I start with him, he's a person, so I don't even need to check whether or not Paul's a person. I'm sure he's hurt by that. But I don't need to check because my condition was or. Well, he's already a person, so I can just stop there. Now, if it's an and, if I say a person, that would be a double ampersand, then I do need to check. I need to check every single thing that I'm checking. He's a person, and he's a person, and he's a person, but you know, that chair is not. So that would cause the whole thing to be false with, or if any one of them is true, then the whole thing is true. And that's just a shortcut way of saying this had better work, or if it doesn't work, do this thing over here, which is usually a die or a, you know, throw an exception or write something to a log file, whatever you want to do to say, hey, this thing didn't work.
So
Good question.
That's a little bit different than a logical or, because it's saying if the left side isn't true, then do the right side. Or if the left side is true, do the right side.
No, because it's short-circuiting with the, because basically,
there's no or condition on the left side though. Or the
well,
right side.
there is, because open returns a true or a false based on whether or not it succeeded in
No, I
opening the
understand
file.
that part. The open is going to return a true or a false.
Yes.
But
And
the right side is not going to.
this doesn't matter though. If this succeeds, this doesn't matter.
No, but I'm saying, does that evaluate to a true or a false?
It evaluates to a, it doesn't even check.
Well,
Because this thing is
That's
true.
right. And what I'm saying is that if you're doing a logical or,
Yeah.
let's say you have two things in parentheses and you say
Yeah.
this or this
Yeah.
is true,
Yeah.
then you evaluate the block. And in a logical one, it says if it's an or.
But if it's an
the
or-
if the first one is false, it'll check the second one.
Yes, and that's true.
But-
that means
but
the
there's
open
nothing being checked
failed.
on the second one here.
Well, there's nothing being checked, but this will be evaluated. So it really doesn't matter at this point. Maybe you could say abusing it, but it's very commonly used in Perl.
Another way. If the left side,
This won't be executed unless this is false. If this is false, this is executed. And it really doesn't matter whether this is true or false because I'm killing the program anyway, so I don't really care whether it's true or false.
Okay,
The program's dead.
Strictly speaking, it's not really an or because the right side is.
I understand what you're saying, but more or less it's just a convenient way to use the short-circuiting mechanism
right.
to say either do this thing or do this thing.
Because what you're saying is that if the left side is false, I'm going to execute the right side.
Exactly.
You're not
And it's going
just
to,
exercise.
well, but the
Well,
way
yeah,
that,
you're gonna- it's
that's
gonna-
how you
it's gonna
evaluate.
return some value, but you don't care.
But
what
you
the
don't care
value
what it is. Yes,
Right, okay.
correct. Yes.
It's
You
a
could
cheat.
actually put that in an if statement and it would still
So
work.
is it necessary we need to put die or just can we put like print or something?
Yeah, you could put print. You could do whatever you wanted here. It's just usually, like in this case, if I can't open that file, my program's done. There's no way I can recover from that. It can't do anything useful, so it just gives up. With other programs, maybe you've got a way that it can recover and go, oh, well, maybe I can't open this file, but maybe I have this backup file I can write to instead or whatever. Or maybe I can print it to the console if it won't go to the file. Just depending on what your program logic is depending on what you're going to decide to do. In this case, I just give up. Say, file doesn't work, I give up. Okay. I am almost thinking, you know what I'm going to do? I'm going to, whoops, didn't mean to do that. I'm going to save functions and arguments because it is getting awfully darn late. I'm going to put this into the next talk, and we'll call it good at here. And if any of you really want to have questions about functions and arguments before then that desperately need answered, you can always post to the mailing list, and somebody on there will surely be able to help you answer that. So anyways, I apologize for the length of the talk. Thank you all for coming out. I hope you learned something. If you've got individual questions you want to ask me, feel free to come up afterwards. Thank you. And this will also end up on YouTube with the video, and the slides will end up there, and the code will also be there as well, so you'll be able to download and execute that. I'm just showing you my references real quick. This is where I got my information from, except the parts I got wrong, that I got from my own brain. So that's it.
And you'll send out an email saying that this stuff is posted?
Exactly, that will go to the mailing list. So yes, if you're not on the mailing list, make sure you join. Otherwise, you won't get meeting announcements and you won't find out when something's been posted to YouTube. Because we always send out a notification when it's been posted to YouTube, and we put links to all the slides, programs, all that stuff. That way, if you can't make it to a talk, you can always see on the list, oh yeah, they made it to YouTube. You can watch it on your own time. What's that?
I think I still owe you my slides, don't I?
Oh, I can't remember now. It's been too long.
Good job, Doug.
Thank you. Yeah. I knew I was pushing it, there's just too much material to cover in an hour.
Yeah, I think maybe part A, part B.
Would you say double ampersand?
That's a logical and that means that you can have multiple double ampersands, but every single thing that is in between those has to be true in order for the whole statement to be true.
Right.
If any one of them's false, the whole thing's false. Whereas the or, if any part of it's true, the whole thing's true. And that's why you can, as soon as it hits a true value, Perl just stops because it's like, I don't care what's after that next or.
But if
I've already
it's a
figured out
false
it's true.
value, it keeps going.
Yes, if it's false, it keeps going until it hits a true. But the
That's why
first
the
true,
or
you
die
give up.
works.
Yes,
That's why the or die works.
exactly.
And that's what I was trying to say about the, if, that statement would actually work in an if.
Oh, yeah, uh-huh, it would.